I hope everybody is doing well. I am posting another video today to help you with lesson 6-4, which is dilations. I found a video on 6-3 on rotations, and that is definitely the most trickiest lesson there is. I had a hard time finding a way to get you guys a video, and if you need more help or extra support on that lesson, let me know. Email me, and I will get you another video. I will probably make it to try to figure something out to help you as best as I can. But today we have lesson 6-4, which is dilations. Your assignment was page 190, numbers 1 through 3, and page 191, 1 through 5. So dilations, you are enlarging or shrinking an object by a scale factor, right? And if you want to apply it to something, think of like when you go to an eye doctor, right? They dilate your pupils to help do an eye exam. Right? That's kind of the idea, is that they're enlarging it. They're dilating it by a scale factor. Okay? So I'm going to do examples 2 and 3 to kind of help guide you through this lesson. And if you have a scale factor that is bigger than 1, it's going to enlarge the image. If it's less than 1, if it's a fraction, it's going to make the image smaller. It's going to shrink the image. Okay? So I'm going to do examples 2 and 3. On numbers 2, we have an original image. We have to find the image, the new image, given the scale factor, and then plot those points. Notice I have already graphed the original image, and we're now going to take those points and we're going to use the scale factor to find the dilation. Okay? So if we're looking at point R, we have the coordinates 1, 1, and we need to enlarge it or shrink it by a scale factor of 3/4. So what I'm going to do is multiply each coordinate by 3/4. Okay? Since this scale factor is smaller than 1, the image will be smaller. So if I multiply 3/4 by 1, notice R prime, that's my new point, is going to be 3/4, comma, 3/4. Right? We just multiply it by that new scale factor. If I do the same thing with S, we have the point 1, 7, and I go to my S prime, my new point, I'm going to have 3/4, comma, 21/4, which is just 5 1/4, right? So putting it as that mixed number might help you when it comes to graphing, okay? Some of these numbers look, if you look, the numbers aren't nice. They're not going to be exactly on the lines. So we're going to have to be careful when we're graphing these. So if I go with point T, we have 5, 7. And if I go to my new point T prime, 5 times 3/4 is 15/4, which is 3 3/4. Okay? So if I 3 3/4 is my x coordinate. And my t, for my y coordinate, it is the same thing as s, which is 5 1/4. And then my last point, u, we have the coordinate 5, 1. So we have u prime multiplied by 3/4. So that's going to be 3 3/4, comma, 3/4. And now I can plot my new points. I'm going to use a different color. And if we plot R prime, that's going to be at 3/4, which is not quite at 1, and then not quite at 1 again. So 3/4 is probably about there. Okay. So this is R prime. Okay. Let me go back and label these ones. This was R. This was S. This was T. And this was U. And if I go back and label now, S prime is 3/4, 5 1/4. So I'm going to stay at that 3/4 mark and go up 5 and then up 1/4. So about right in there is 5 1/4. And then we have 3 3/4. So I'm going to go over 3 and not quite another one, and up 5 1/4. So it's going to be about right there. And my last one is 3 3/4, comma, 3/4. So I have to finish this rectangle. So that would be right there. And now I will label my points as prime, T prime, and U prime. And now I can draw my image. See how this goes. Okay. So something like that. Okay. Notice the image shrinks. It gets smaller by a factor of 3/4. Okay. So that's kind of the idea behind number 2, and that will help you with some of the graphing ones that are similar to question 2. With question 3, we are not given a graph anymore. We have to figure out the scale factor given the new dimensions. Okay? And in order to figure this one out, you will need to do a simple calculation, and it's going to be pretty much the same every time. You're going to have your new image, so your new image divided by your original. Okay, and that will always give you your scale factor. So keep in mind, if your object's getting bigger, it's going to be bigger than 1. If it's going to get smaller, it's going to be a fraction smaller than 1. Okay, so it's the new image divided by the original. So on number 3, a graphic designer created a logo on an 8.5 by 11-inch paper. But in order to be placed on a business card, the logo needs to be 1 7/10 by 2 1/5. What is the scale factor of the dilation? So to figure out the scale factor, remember we take the new image, okay, and divide it by the original. So if it's 1 7/10 by 2 1/5, and we're going to divide it by 8 1/2 by 11. Okay? Now, I'm not going to do this whole calculation. I'm actually only going to take each part here. Okay? So this divided by this, and this divided by this. Okay? So the first one I'm going to take is 1 7/10 divided by 8 1/2. Now, you can plug this directly into your calculator, and you will get the answer. Okay? Or you could do it by hand. Remember, dividing by a fraction is like multiplying by the reciprocal. Okay, so you could make this into improper fractions. So this one would be 17 over 10, and this one would be 17 over 2. And if you multiply by the reciprocal, so this is the same thing as 17/10 times 2 over 17. The 17s cancel, so we're left with 2/10, which is the same thing as 1/5. Okay, so that is my scale factor. You don't even have to do this division right here because the scale factor has to be the same. Okay, so your scale factor for the dilation is 1/5. All right. If you need more help with that, please let me know. I will post another video to kind of help guide you. And if you need help with the rotations, also send me an email on that as well. Hope this was helpful, and keep up to date on your ALEKS assignments, please. You're doing a great job. Keep up the good work. Thanks.